are going to take examples of Kc and Kp. Let's look at this example. Write the equilibrium expression for each equation above if the concentrations are halved, if the equations are reversed, and if the equations are reversed and halved. Now look at it. If the concentration is half, how do we express it? So for the first one, we have CO2, two molecules of CO2 decomposing to give us 2CO plus O2. The first thing you do is to check if the reaction is balanced. Is it balanced? Yes, it is balanced. The next thing is, if the concentrations are half, that means we know that the concentration is the stoichiometry of the reaction. So divide up by half. We will have this, and we will have this, and we will have 1 over 2. So it becomes CO2, reverse reaction to CO plus 1 over 2 O2. So you look at it again, is it balanced? If it's half, yes. Then represent the Kc. Therefore, the Kc will be equal to concentration of CO and O2 half all over concentration of CO2. This answers the first question, which is if the concentrations are half. Now, the second one, if the equations are reversed, if it is reversed, you know we said this is forward, then reverse. If it is reversed, it therefore means that Kc will be equal to CO2 raised to power 2 all over CO concentration and O2 concentration. Remember that here is raised to power 2 from the original equation. So from the original equation, this is the reversed form. Now, lastly, if the equations are reversed and half, that means now we have reversed it. What will be the concentration, the equation if it is half? If the equation is half, then it will now be Kc will be equal to just half this, half it. What will be it? It will be CO2, concentration of CO2 all over concentration of carbon monoxide over concentration of oxygen raised to power half. That is when the reaction is what? Reversed and the reaction is reversed and halved. So this is how the Kc will be represented. So you can do the second equation and send it on the comment section. Look at, consider the following equilibrium process at 700 degrees Celsius. We have 2 moles of hydrogen gas reacting with sulfide gas to give us H2S, which is hydrogen sulfide, 2 moles. Analysis shows that there are 2.8 moles of hydrogen gas, 1.35 moles of sulfur gas, which is sulfide, and 8.70 moles of H2S present in a 20-liter flask at equilibrium. Calculate the equilibrium constant concentration for this reaction. So what will be the equilibrium constant? Simple. You first of all do the expression before you can now calculate the equilibrium constant. And how do you do the expression? They said the moles of each of them were given to us. And we know that concentration is equal to what? Mole over liter. That is mole per dm cube or mole per liter. That is how concentration is. So they gave us the concentration for hydrogen sulfide. For H2, first of all, how many H2 do we have? We have 2 moles. But in calculating the concentration, you don't need to put 2 moles. But if you also put the 2 moles, it's not a problem. So what is the number of moles of nitrogen? Is 2.80 all over 20. That will give us the concentration. The concentration is 0.14 mole per liter. Apply the same for sulfur, which is sulfide, and that is 1.35, and the liter is 20, which is equals to what? The concentration will now be 1.35 divided by 20, and that will give us what? 0.0675 mole per liter. Now the next step is to do that of what? Hydrogen sulfide. That of hydrogen sulfide. And what is the number of moles? 8.70 per liter. So that will give us 8.70 divided by 20, and that will give us what? 0.435 mole per liter. So we have gotten the concentration. The next thing is to now know the equilibrium constant. Remember that the equilibrium constant expression will be that of products, concentration of the products raised to power what? 2, because it has 2 coefficients, all over concentration of hydrogen raised to power 2 times the concentration of sulfide raised to power 1. Because as it is, like I said, the first step is to check if the reaction is balanced. And now the reaction is balanced. So evaluate your Kc. H2SO4, what was your concentration? 0.435. So you must put it raised to power 2. What will be the concentration of hydrogen? You calculated it to be 0.14, and it will be raised to power 2. Then that of sulfur will be 0.0675. So simplify it, and that will give us the value of what? Kc. So this is the value of Kc. When you press your calculator, you see that Kc is equal to 143.027. The next thing is to now calculate for Kp. How do you calculate for Kp? From the relationship that we derived, that Kp is equal to Kc ROT raised to power delta N, where delta N is the moles of the product minus moles of the reactant. So calculate Kp. Kp is equal to what? Kc RT delta N. And we said delta N is number of moles of product minus number of moles of reactant. What is the number of moles of product? 2. Number of moles of reactant is what? 3. So delta N is equal to 2 minus 3, which is delta N equals to minus 1. And we calculated Kc to be 143.027. So R is our R constant of 0.0826 times, what is the temperature in the question? Temperature is 700. So we say 700 plus 273, because it's always absolute temperature. And that will give us 973. So it means times 973 raised to power minus 1. So that means Kp will be equal to, so we will press our calculator right now to get Kp, 143.03 times 80.37 raised to power minus 1. So what is the inverse? The inverse is what? 0 times 1 equals to 1.779, which is approximately 1.8. 1.8. So Kp and Kc does not have a unit, and because it's what? A constant. So Kp is 1.8, Kc is 143.03. Thank you, and please keep on watching ChemTech Laboratory tutorial. Don't forget to like, share, and subscribe. Thank you.